This is number 1 of 4.6. With time, T, in minutes, the temperature, H, in degrees Celsius, of a bottle of water put in the refrigerator at T equals 0, in other words, when time starts, is given by this equation. H, the temperature, is 4 plus 16 e to the negative 0.02 T. Given how ugly those numbers are, I'm guessing that this is probably pretty realistic. How fast is the water cooling initially after 10 minutes and then give units? Well, as always, I like to sketch a graph. I know that I know what the function e looks like. It usually goes up like this. But since we have a negative, then with negative values, it's going to go up higher. And with positive values, it's going to go down lower because you've got 1 over e when it's negative. At any rate, the point here is that we're looking at the slope of this function. So if this is h in degrees Celsius and this is time, then the slope of that function is going to be degrees per minute. So the first question is, what is the slope of the tangent line right about there when it's tangent to the time being equal to 0? So what we can do is we note first of all that if I put 0 in for t, I'm going to get the function at time 0 is 4 plus 16, which is 20, which means that when it first goes in, it's 20 degrees Celsius. It also makes sense that the temperature is decreasing because we're putting it in the refrigerator. So to figure out how fast it's cooling, we want to find the derivative. Well, that's 16 e to the negative 0.02 t times the derivative of the exponent, which is negative 0.02. So this simply becomes negative 0.32 e to the negative 0.02 t, because e to anything is e to that something times the derivative of that something. So we have here, when I put in 0, because that's how fast the water is cooling initially, I have f of prime of 0 is negative 0.32 e to the 0 power. And anything to the 0 power is 1, so we have negative 0.32. So the slope right here of this tangent line is negative 0.32 degrees Celsius per minute. Now, the second question is after 10 minutes. So after 10 minutes, we can assume that it's not slowing down as fast. So it's going to be more like this. So you can see how it's less steep there. It's still negative, but it's less steep. So I'm going to put 10 into this same derivative here. And I'm going to get negative 0.32 e to the negative 0.02 times 10, which is negative 0.32 e to the negative 0.2. And when you use a calculator, you find that's negative 0.262 degrees Celsius per minute. That's how we would do it without a calculator or without a computer. You can see here, I was pretty close with my function here. It actually looks like this, but since we're really talking about time on the x-axis here, really I'd have to limit the domain to be 0 because you can't really have negative time. So it looks more like that. So then the question becomes the same idea here. I'm going to use my little calculus tool, and I'm going to say if this is the function, what is the slope of the tangent line? So put this tangent line here, and we see that when I started here at 0, the slope of that tangent line is negative 0.32, as we figured out. And then when I move it down here to 10 minutes, see here, about 9.95, that's probably about as good as I'll get it. It's negative 0.26. So I hope these two help you understand.